South Africa's geology tells a remarkably long and layered story. We're dealing with some of the oldest preserved crust on Earth, anchored by the stable Kapval Craton. Around it, we see ancient greenstone belts, world-class mineral systems, like the Witwatersrand and Bushveld, vast Karoo basins, folded mountain belts, and even a giant meteorite impact. Together, these features record a journey from early crust formation through continental assembly and breakup, uncovering both South Africa's extraordinary mineral wealth and many of its geological engineering challenges.
The Karoo supergroup begins in the late Carboniferous to early Permian, at a time when southern Gondwana lay close to the South Pole. The earliest Karoo sediments were deposited in glacial and glaciogenic marine environments, recording intense continental glaciation. These conditions produced distinctive rocks such as diamictites, finely layered varved shales, and isolated drop stones. Together, they preserve clear evidence of the southernmost glaciation experienced by Gondwana, and set the climatic stage for the rest of the Karoo succession. The Drakensberg group represents the dramatic volcanic climax of the Karoo sequence and dates to the early Jurassic. During this time, enormous volumes of magma were erupted as continental flood basins, producing thick, laterally extensive lava flows dominated by foliatic basalt with only minor rhyolite. This volcanism is closely linked to the initial breakup of Gondwana and forms part of the Karoo Large Igneous Province, one of the most extensive volcanic events recorded on the African continent.
Within the Stormberg, at the top of the tar-casted subgroup, lies the Clarence Formation, dominated by thick, wind-blown sandstones that record arid desert conditions and form the final sedimentary unit before volcanism. Beneath this is the Elliott Formation, composed mainly of red and yellow mudstones and sandstones, deposited on semi-arid floodplains, and famous for its early dinosaur fossils, including Massospondylus. At the base of the subgroup is the Molteno Formation, where fluvial sandstones deposited by braided river systems preserve abundant fossil plants and insects, along with thin, localized coal seams. The Beaufort group represents a long period of continental deposition from the late Permian into the early Triassic. From top to bottom, it consists of fixed successions of mudstones and sandstones laid down on broad fluvial floodplains by meandering river systems. These sediments preserve an exceptional vertebrate fossil record, divided into well-defined biozones based mainly on fossil reptiles. Because of this, the Beaufort group is used internationally as a key reference for terrestrial biostratigraphy, particularly across the critical Permian-Triassic transition. The Ecker group records a major phase of marine to deltic sedimentation within the Karoo Basin. At the top of the succession is the Volksrust Formation, dominated by shales and siltstones, and together with the underlying Freehead Formation, it hosts South Africa's main Karoo coal deposits. Beneath this, the Middle Ecker consists of the White Hill, Collingham, and Freehead formations, representing deeper water, turbiditic, and deltatic environments. At the base of the group lie the Prince Albert and Pietermaritzburg formations, characterized by organic-rich black shales that reflect quiet, low-oxygen marine conditions. At the base of the Karoo supergroup lies the Dwicker group, representing the earliest phase of Karoo deposition. From top to bottom, it consists of glaciomarine and glacial sediments deposited during the late Carboniferous to early Permian, when southern Gondwana was positioned near the South Pole. These deposits include massive diamictites, finely laminated shales, and drop stones released from melting icebergs. The Dwicker group provides clear evidence of widespread Gondwanan glaciation and forms the foundation upon which the rest of the Karoo Basin succession was built. The Bushveld igneous complex is a Paleoproterozoic feature emplaced about 2.06 billion years ago, and represents one of the most remarkable igneous bodies on Earth. It is a vast, layered mafic to ultramafic intrusive complex that was emplaced into the Transvaal supergroup under relatively stable cratonic conditions. What sets the Bushveld apart is its sheer scale and internal layering, which have concentrated enormous mineral wealth, making it the world's largest known layered intrusion and the primary global source of platinum group elements, as well as chromium, vanadium, and several other strategic metals. The Bushveld igneous complex occupies much of South Africa's northern interior, extending across Limpopo, Northwest, Gauteng, and Mpumalanga. It forms a vast, gently curved basin, more than 400 kilometers in diameter, centered around areas such as Pretoria, Rustenburg, Polokwane, and Lydenburg. At the surface, this geometry is expressed as low, arcuate ridges surrounding broad, flat plains, features that represent the frozen roots of an enormous ancient magma system. Within this system are the world's richest concentrations of platinum group metals, along with major deposits of chromium and vanadium. Overlying the intrusive Bushveld rocks is the Rooiberg group, which represents the extrusive volcanic phase of the Bushveld magmatic event. Unlike the layered intrusions below, the Rooiberg group consists of lava extrusions, erupted onto the surface during late-stage magmatism. These volcanic rocks are predominantly felsic in composition, made up mainly of rhyolites and dacites, indicating highly evolved, silica-rich magmas. The Rooiberg volcanics form extensive sheets of lava and volcanic material, preserving the surface expression of the Bushveld event and marking the final volcanic activity in the region. At the top of the Bushveld sequence lies the Leboa granite suite, representing the final intrusive phase of Bushveld magmatism. These rocks are felsic intrusive granites, emplaced after the main layered mafic sequence had largely solidified. The suite is subdivided into several granite bodies, including the Naoni granite, the Makatso granite, the Bobbejaankop granite, the Lees granite, and Klipkloof granite. Together, these granites mark the waning stages of magma evolution, dominated by silica-rich knelts, and they represent the last major intrusive activity associated with the Bushveld magmatic event. Separating the mafic layered rocks below from the felsic units above is the Rashop granophyre suite. This suite consists of granophyric rocks that form the roof of the Rustenburg layered suite, marking the uppermost boundary of the main mafic intrusion. In composition, the Rashop suite is dominated by granophyres and other felsic rocks, reflecting increasing silica content as the magma system evolved. The Rashop granophyre suite is significant because it represents the transition zone between the underlying mafic Rustenburg layered suite and the overlying felsic intrusions and volcanic units, linking the intrusive and extrusive phases of Bushveld magmatism. The Rustenburg layered suite forms the main mafic, ultramafic body of the Bushveld igneous complex. It is directly overlain by the Rashop granophyre suite, which marks the transition from the mafic layered intrusion below to the younger felsic units above. At the top of the Rustenburg layered suite is the upper zone, which is characterized by magnetite-rich layers and gabbros, reflecting late-stage differentiation of the magma and the concentration of iron-titanium oxides. Beneath this is the main zone, composed predominantly of fixed successions of gabbronorites, with only minor anorthosite layers, indicating more uniform crystallization from a large, relatively evolved magma body. Below the main zone, we enter the critical zone, which is of particular economic importance. This zone contains multiple chronotite seams grouped into the lower, middle, and upper chromatite series, as well as the famous Merensky Reef, all formed through repeated magma replenishment and crystal sorting. Underlying the critical zone is the lower zone, dominated by ultramafic rocks such as pyroxenite, harzburgite, and dunite, representing early crystallization of magnesium-rich minerals from primitive magma. Finally, Along the base and margins of the intrusion, the marginal zone consists of fine-grained norites and gabronorites that formed where the magma cooled rapidly against the surrounding country rock. The Transvaal supergroup was deposited during the Paleo-Proterozoic between approximately 2.65 and 2.05 billion years ago. It accumulated on a stable K-up fault craton within a long-lived intracratonic basin and was later intruded by the Bushveld igneous complex. Deposition took place across a range of environments, from shallow marine carbonate platforms to deeper marine clastic settings, with episodes of continental volcanism. The Transvaal supergroup is of major economic and geological importance, hosting significant iron and manganese deposits, extensive dolomites that form important groundwater aquifers, and widely used building stone. The Rooiberg group is made up mainly of felsic volcanic rocks, including rhyolite and dacite, with associated volcaniclastic deposits. It records a major volcanic episode that immediately preceded the Bushveld igneous complex. Although it has little direct economic value, the Rooiberg group forms a resistant volcanic cap and plays an important structural and thermal role in Bushveld emplacement. It belongs to the Upper Transvaal supergroup and forms the volcanic floor to the Rustenburg-Laird suite. Beneath the Rooiberg volcanic rocks lies the Pretoria group, a thick succession of shales, mudstones, quartzites, and minor volcanic units. These sediments record deeper marine to deltaic conditions within the Transvaal basin and host important iron and manganese mineralization. Although less economically significant than the Tunispoort carbonates and the Bushveld complex, the Pretoria group is a key marker sequence for understanding basin evolution. The Tunispoort group lies directly beneath the Pretoria group and is dominated by thick dolomites and limestones, with abundant stromatolites. These carbonates are interbedded with chert and banded iron formations, and rest on the basal Black Reef Formation. The Black Reef marks renewed uplift and erosion at the onset of Tunispoort deposition, forming a coarse quartzite that later became an important gold-hosting horizon, where it overlies the Witwatersrand supergroup. Together, the Tunispoort rocks record early oxygenated, shallow marine environments. They host major iron ore deposits in the Penge area, while the Mamani Dolomites form vital regional groundwater aquifers and are also responsible for sinkhole hazards in parts of Gauteng and the northwest. The Ventersdorp supergroup dates to the late Archean, between about 2.71 and 2.64 billion years ago. It formed during a period of rifting and widespread volcanism on the Kaapvaal Craton, occurring during and shortly after deposition of the Witwatersrand supergroup. Stratigraphically, the Ventersdorp supergroup unconformably overlies the Witwatersrand supergroup and is itself unconformably overlain by the Transvaal supergroup. Economically, it hosts hydrothermal gold, uranium, and base metal mineralization, and plays a key role in reconstructing the tectonic evolution of the Kaapvaal Craton. The pineal sequence forms the uppermost part of the Ventersdorp supergroup. It is characterized by quartzite-bearing sedimentary rocks, overlain by mafic to intermediate lavas. This succession reflects a clear transition from vigorous volcanism to waning volcanic activity and increasing continental sedimentation. Importantly, the pineal sequence records the stabilization of the Kaapvaal Craton, marking the shift toward the more quiescent conditions that precede deposition of the Transvaal supergroup. Beneath the pineal sequence lies the Platberg group, which records a more complex and dynamic phase of Ventersdorp evolution. Here we see intercalated andesitic to felsic volcanic rocks, together with volcaniclastic sediments, conglomerates, and sandstones. These deposits formed in a rift-controlled basin, where episodes of volcanic activity alternated with periods of sedimentation. The Platberg group captures an unstable, evolving rift environment rather than a single volcanic pulse. At the base of the Ventersdorp supergroup lies the Klipper-Friersberg group, the foundational volcanic unit of the succession. It is dominated by thick komatitic to basaltic lava flows, locally pillowed with minor tuffs. These lavas erupted mainly from extensive fissures in a proximal rift setting, representing the largest preserved volcanic pulse of the Ventersdorp. The Klipper-Friersberg group marks the onset of widespread crustal extension and volcanism on the Kaapval-Kraton. The Witwatersrand supergroup was deposited between about 3.0 and 2.7 billion years ago, during the late Archean. It formed on a stable, ancient continent that gradually sagged into a broad sedimentary basin as plate collisions along the margins of the Kaapval-Kraton caused the crust to bend. This basin hosts the world's most productive gold province, divided into several major goldfields along its northern and western rims. The Witwatersrand Basin is a large, gently curved sedimentary basin made up of the Dominion, West Rand, and Central Rand groups. In map view, it forms what geologists often call the Golden Arc, an elliptical belt about 300 kilometers long. You can trace it counterclockwise from the East Rand around Johannesburg through the far West Rand and Free State goldfields, and back toward Balfour and Evander. This geometry reflects both basin subsidence and later tectonic modification. The Central Rand group represents the youngest and most economically important part of the Witwatersrand supergroup. It is dominated by coarse conglomerates and quartzites deposited by high-energy braided river systems flowing across a broad alluvial plain. Stratigraphically, the Johannesburg subgroup sits at the top and hosts the famous carbon leader and main reef horizons. Beneath it, the Turfentine, Ellsberg, South Rand, and Basal Buizens formations record repeated pulses of sediment influx that ultimately concentrated the world's richest gold deposits. The West Rand group features the Jeppestown subgroup at the top of the succession, reflecting increasing clastic input as the basin progressively shallowed. Beneath this, the Government subgroup represents continued marine sedimentation under increasingly shallow conditions. The Basal Hospital Hell subgroup records the earliest phase of deposition, dominated by deep water, turbiditic environments. Transitional units such as the Newlands and Kransport formations mark the shift from marine to fluvial sedimentation, leading into the Central Rand group. The Dominion group forms the basal unit of the Witwatersrand Basin and represents the earliest phase of sedimentation. It is dominated by coarse fluvial deposits, including braided river conglomerates and quartzites, laid down in high-energy stream systems prograding across an extensive alluvial plain. These sediments record the initial infilling of the basin and provide the foundation upon which the West Rand and Central Rand successions were later deposited. The Wits Basin spans several distinct geographical regions. They are the East Rand Goldfield, the Central Rand Goldfield, the West Rand Goldfield, the Far West Rand Goldfield, West Wits Line, the Klerksdorp Goldfield, the Orange Free State Goldfield, the South Rand Goldfield, and the Evander Goldfield. The East Rand Goldfield represents a structural sector of the Witwatersrand Basin, in which the reef horizons generally have a shallow dip towards the south. A key geological feature of this area is the Boksburg Gap, where certain reefs are locally absent as a result of erosion or non-deposition. Mining in the East Rand has focused primarily on the main reef leader and the Kimberley Reef, also known as the UK 9A or May Reef, with additional exploitation of the overlying Black Reef of the Transvaal supergroup. Major mining operations have included Sub-Nigel and ERPM in the past, with Modder East currently active and ERGO continuing large-scale tailings retreatment. The Central Rand Goldfield represents the historical heart of the Witwatersrand Basin, centered on the Johannesburg area. Structurally,
It is characterized by steeply dipping strata close to surface outcrops, which gradually flatten with increasing depth, allowing for extensive deep-level mining. Gold production in the Central Rand focused primarily on the Main Reef Leader, and the South Reef. This area hosted many of the basin's most famous mines, including Crown Mines, City Deep, Robinson Deep, and Village Main Reef, all of which are now closed. ERPM, located along the eastern margin of the Central Rand, is the last underground operation to remain active in this sector. The West Rand Goldfield is structurally dominated by the Witpoortjie Horst, a major uplifted block that brought several gold-bearing reefs closer to the surface. This structural uplift played a key role in making the reefs more accessible for early mining. Gold production in the West Rand focused on the Kimberley Reef, South Reef, Main Reef, and the Bird Reef. Major mining operations in this area included Randfontein Estates, West Rand Consolidated, and Durban Rue de Port Deep, all of which are now closed. The Doornkop mine remains the only active operation in the West Rand Goldfield today.
The Westwits line, centered around Carletonville, represents the deepest and most technically challenging part of the Witwatersrand Basin. In this area, the gold-bearing reefs are buried beneath thick sequences of Transvaal dolomite and Ventersdorp lavas, and were originally identified through magnetic and geophysical surveys rather than surface outcrop. Mining in the Westwits line targets some of the basin's most economically important reefs, including the extremely high-grade Carbon Leader Reef, the Ventersdorp Contact Reef, and the Middelvlei Reef. Major mining operations include Meponing, Driefontein, Kloof, and Kossicelita, while Blyvoortzicht represents an important historical producer. The Klerksdorp goldfield is distinguished by its intense structural complexity. It is a severely faulted part of the basin, where gold-bearing reefs are commonly offset by faults with displacements of hundreds of meters, presenting major challenges for mine planning and continuity. Despite this, the field has been highly productive, with the Vaal Reef serving as the principal ore horizon. Additional mining has targeted the Ventersdorp Contact Reef and, at the base of the succession, the Dominion Reef. Active operations include Kopanan, Moab Kotsum, and Taulekoa, while Stilfontein, Buffelsfontein, Hartbeestfontein, and Vaal Reefs represent important historical producers. The Orange Free State Goldfield represents the southernmost extension of the Witwatersrand Basin. In this area, the gold-bearing reefs are deeply buried beneath Ventersdorp volcanic rocks and younger Karoo sediments, leading to some of the greatest mining depths in the basin. Mining has focused primarily on the Basal Reef, equivalent to the Vaal or Carbon Leader, as well as the Leader Reef and the A and B reefs. Active operations include Beatrix and Target, while Western Holdings, Free State Geduld, St. Helena, and Harmony are important historical producers. The South Rand Goldfield forms a smaller and more isolated sector on the southeastern margin of the Witwatersrand Basin. This area is characterized by complex faulting and generally thinner reef development compared to the major goldfields to the north and west. Mining here has focused primarily on the Kimberley Reef, commonly referred to locally as the Kimberley-Ellsberg sequence. Current activity is centered on the Burnstone project, which has operated intermittently and remains under development. The Evander Goldfield forms an isolated subbasin on the eastern margin of the Witwatersrand Basin. It is buried beneath roughly 1 kilometer of Karoo supergroup sediments and is folded into an asymmetric syncline. Unlike other goldfields, mining at Evander has focused exclusively on a single economic horizon, the Kimberley Reef. Current production is centered on Evander 8 shaft, while Winkelhack, Kinross, Leslie, and bracken represent earlier operations that have since been consolidated or closed. The Witwatersrand Basin remains the most significant gold-producing region in human history. Formed more than 2.7 billion years ago, this approximately 300-kilometer-long golden arc has yielded over 1.5 billion ounces, more than 40,000 tons of gold. This represents roughly one-third of all the gold ever mined on Earth. Beyond its extraordinary economic importance, the Witwatersrand stands as a unique geological archive, linking early Earth processes, basin evolution, and mineral concentration on an unparalleled scale. South Africa's geology tells an exceptionally long and complex geological story. From the early formation of stable continental crust on the Kaapvaal Craton, through greenstone belt volcanism, major sedimentary basins such as the Witwatersrand, large igneous events like the Bushveld Complex, and later deformation in the Cape Fold Belt, the country preserves a near-continuous record of Earth history. These processes created extraordinary mineral wealth, but they also resulted in structurally complex and geotechnically challenging ground conditions. Understanding this geological framework is therefore essential not only for resource exploration, but also for safe mining, infrastructure development, and sustainable land use.